All right, we're gonna treat page 678 like a bell ringer. So we'll start on 678 and we'll go all the way through 680. And you should have these notes from Friday. All right, so let's take a look at number 3. It says a spinner has 5 equal size sections, number 1 through 5. The spinner is spun only once. Is it more likely that the spinner will land on an even number or an odd number? Let's take a look at how many even numbers we have. 2 is an even number, and 4 is an even number. Those are the only even numbers. An odd number will be 1, 5, and 3. Those are the odd numbers. It is more likely that it will land on an odd number because there are more of them. I'm going to use BC for because. All right, 2, how likely is it that it'll spin on a, 3B, how likely is it it will spin on a 1? Well, it's only 1 out of the whole section, so that is unlikely. C, why is it just as likely to spin on a number greater than 3 as a number less than 3? Well, let's take it the numbers greater than 3. That would be 4 and 5. 4 and 5 are greater than 3. And then the numbers less than 3 are 1 and 2. So it's the same amount. So I'm going to put equally likely. Because you have the same number of outcomes per event. You have 2 outcomes here and 2 outcomes there. Use the spinner from problem 3. What are the possible outcomes of spinning the spinner? So the possible outcomes are just all the outcomes on the spinner. So if you look at all the outcomes on the spinner, you have a 1, 2, 3, 4, and a 5, guys. Those are the outcomes, or the possible outcomes. What are the possible outcomes for spinning a prime number? Remember I told you all 1 was neither prime nor composite. So let's look at the outcomes of prime. So the number of ways I can get a prime number would be 2, 3, and 5 from that spinner. Those are the prime numbers on the spinner. So that would be all the possible outcomes for landing on a prime number. All right, what are the possible outcomes for spinning a factor of 4? Factors of 4. Let's see, what are the ways to get 4? 1 times 4. So 1 and 4 are factors. And 2 times 2. So 2 is a factor. So if I look at all the factors of 4, there would be 1, 4, and 2. No, those are your possible outcomes of spinning a factor of 4. 1, 4, and 2, guys. All right, D, for D, what are the possible outcomes for the event of spinning an even number? Okay, so I'm looking at my even numbers. My even numbers are only 2 and 4. 2 and 4 are the only even numbers. And the odd numbers were 1, 3, and 5. So this to me kind of mimicked 3A. Kind of, but it's just actually which one is it more likely to land on in 3A. But 3 4D actually for the outcomes. Let's look at 5. Suppose you spin the spinner from problem 3 once. Give the possible outcomes, if any, for each event. All right, so spinning a number less than or equal to 2. So keep in mind you got the numbers 1, 2, 3, 4, and 5 on the spinner. All equal size pieces. I'm going to write them down here so I don't have to keep looking back up there. All right, spinning a number less than or equal to 2. That would be 1 or 2. Okay, that's unlikely because there's only 2 out of 5. Spinning a factor of 6. So you think about factors of 6. 1 times 6 and 2 times 3. So 1, 6, 2, and 3. Well, that's almost all of them. That's 4 of the 5 numbers, so that's likely. All right, spinning a 6. Okay, there are none. There are no 6s. So it's impossible to spin a 6. There are no 6s in this sample space, okay? This is what you call sample space. This whole thing is a sample space. All right, let's take a look at page 679. And we're going to look at number 1. A bag contains 6 red marbles, 6 green marbles, and 12 blue marbles, which is 24 marbles in all. Paloma reaches into the bag and selects a marble without looking. So what's the total number of marbles in the bag? Well, that would be 24. What is half of the number of marbles in the bag? Well, half of 24 is 12. Name an event that is impossible. Well, it's impossible to pick a yellow because you don't have any yellow marbles. Name an event that is unlikely. So something that we could say is unlikely to happen. And you could just go with, I'm going to go with selecting a red marble. You could go with selecting a green. I wouldn't go with selecting a blue. Because if you select a red marble, that's like only 6 of them out of 24 of them. Name an event that is equally likely as not. That would be selecting a blue. And the reason being is because you have 12 blue and 12 that are not blue. So that's equally likely. Those that are not blue are either green or red. Name an event that is likely. So I'm going to put 2 of them together. So an event that would be likely would be maybe selecting a blue marble, a blue or a red marble. Because if I use the word or, I have to put them together. So I know it's 12 blue and 6 red. So that's like 18 out of 24. That's likely to happen. That's 18 marbles out of the 24. It's only 6 that are not. But I couldn't possibly get it with just 6 ways, and that's if I picked a green. But 6 compared to 18, 18 is way more than 6. All right, name an event that is certain. Selecting a red, green, or blue marble. Definitely certain. Because I'm going to select one of them. So that's 100% or 1 in terms of a regular number. 1 whole. It's definitely going to happen. All right, let's look at 2A. Draw a line from each event to show the probability of that event. All right, but it says consider the experiment in problem 1. Well, problem 1 had 6 red marbles, 6 green marbles, and 12 blue marbles. So I'm going to write these down here so I don't have to keep looking back up there. I had 6 green marbles, 6 red marbles, and 12 blue marbles. All right, selecting a cube. Well, you're not going to select a cube because there are no cubes in the bag. So that's impossible. All right, selecting a red, green, or blue marble. I just did that right here. That is definitely certain because you got a green, red, and blue. So you're going to get one of them. So this would definitely be certain, which is, so guys, I want to make sure you understand something. Your probability can fall between, as a fraction, your probability can fall between 0 and 1, or I should really say can be from 0 to 1. To make sure it's inclusive. If I say between, between kind of sounds like it doesn't include 0 nor 1. But a probability fraction can go from 0 to 1. All right, so as a percent though, as a percent, it is from 0%, which is impossible, to 100%, which is certain. Okay? So you have to kind of keep in mind what you're talking about. If you're just looking at a fraction itself, I don't want that comment. Cancel, please. All right, markup is what I'm trying to get. So as a fraction, the probability can range from 0 to 1. But as a percent, the probability ranges from 0% to 100%. So I'm going to add these guys. I'm going to add, these are the numbers as fractions. But as percents, that would be 0%, 1/2 would be 50%, and 1 would be 100%, okay? All right, so you can express your probability. You can express your probability as a decimal, you can express it as a fraction, or you can express it as a percent. All right, as a decimal, let me do this one. As a decimal, 1/2 is 0.5. So you can also express them as decimals. Decimals, fractions, percent. But 0 is 0 as a decimal. 1 is 1 as a decimal. You can put 1.0. All right. Selecting a red or green marble. Selecting a red or green, that's 16. No, it's actually 18. It's I'm doing red or green. I'm thinking about red or blue. Sorry, it's my fault. Selecting a red or green. Okay, so that would be 12 out of 24. So that would be equally likely. So it's going to go here to exactly 1/2. Okay, equally likely as not. So that's 0.5 as a decimal, 1/2 as a fraction, or 50% as a percent. Okay, so selecting a red or green is 12 out of 24. It's equally likely that you'll get a red or green as it is you get a blue. So that's 0.5 as a decimal, 1/2 as a fraction, or 50% as a percent, okay? Hope that makes sense. All right, selecting a green one. So green is green is only 6 out of 24. It's 6 green out of 24 total. So let's go here and say that's unlikely. Selecting a blue or red marble. Blue is 12, and then red is 6. That's what I was thinking about just a minute ago. That's 18 out of 24. So 18 ways to get it, only 6 ways not to. So it's highly likely we'll pick a red or blue. B, explain why an event is equally likely as not has a probability of 1/2. Well, you have the same amount in each one. When you got equal parts. Okay, equal outcomes, or a 50-50 chance of getting either one of them, okay? Only if the outcomes are equal. Then the probability is 1/2. 1/2 means 50%, okay? Or 50-50. All right, look at 3. And I hope everybody understands this. Equally likely as not. Something is calling on me. Okay, equally likely as not means that half of them, like selecting a red or a green marble. Not red or green, but yeah, that's going to be red or green. So red or green. You select the red or green, that's 12 out of the 24. But then those that are not red or green will be the blue. If it's not red or green, means it's blue. It's also 12 of those. So it's the same amount of outcomes in each event. So that's 50% chance here, 50% chance there. A 50% chance is just 1/2. Half and half. Let's take a look at 3. You can also use numbers to describe probabilities. So instead of using words, we can use numbers. All right. And we talked about that on Friday, but we're going to go into it a little more today. You can also use numbers. All right. So we're going to look at that. Imagine that the cards shown are face down. So all these really are face down. And you select one card at random. Name an event that has a probability of 0. In other words, there's no way to get it. Okay. So selecting a D would be impossible, guys. There are no D's in the cards. Okay, but you could have put F, Z, M, P. It doesn't matter. Just something that's not there. Name an event that has a probability of 1. So an event that has a probability of 1 would be selecting a card with a letter. Okay, all of them have letters on them. Name an event that has a probability of 1/2. Well, if you take a look at this, you have 3 that are A's and 3 of these are not the letter A. So an event that has a probability of 1/2 would be selecting an A. I also could have put not selecting an A. Name an event that has a probability between 0 and 1, or 0 and 1/2. So this is what I'm going to do for D and E, guys. I'm going to draw a number line. And here is 0. And then over here I have 1. But how many cards do I have? 1, 2, 3, 4, 5. You got 6 cards in all. So in the middle will be 3 out of the 6, or 1/2 in the middle, okay? So anything from between 0 and 1 will have to fall in here. That's between 0 and 1/2. I keep saying 1 when it says 1/2. All right, that's between 0 and 1/2. I'm on D. All right, so if this is 0, then 1 6 is in here, 2 6 is in here. So let's think about something that has a probability of 1 6 or 2 6, because that's in between these. That's in between 0 and 1/2, okay? All right, so anything have a probability of 1 out of 6 or 2 out of 6, and that could be selecting a C. Selecting a C is 1 out of 6. You also could have put selecting a B. That's 2 out of 6, or 1/3, because you can divide them both by 2. So both of those have a probability between 0 and 1/2. All right, and then it's on E. We're looking for something, an event that has a probability between 1/2 and 1. So that's going to be this section right here, guys. Here's 1/2 and there's 1. So I'm looking for something in between here. So if I look at this in terms of 6, if this is 3 out of 6, or 1/2, 3 6, then you got to have 4 6 in here, or you got to have 5 6 in there, okay? And 1 would be all 6 out of the 6. But I'm looking for something in between. So I'm looking for like something with a 4 6 or 5 6 probability. So I could put selecting an A or a B. That's 5 6. Because it's 3 A's and 2 B's. That's 5 6. And that's in between 1/2 and 1. All right, let's take a look at 4. Guys, it will tell you on E, you could have put selecting an A or C. That's 4 6. All right, 4, what word describes the probability of rolling an integer on a standard number cube? Well, an integer is just a regular number, and all of them are regular numbers, so the word to describe that would be certain. You're going to get an integer. You're going to get a regular number. All right, how can you describe the same probability with a number? If it's certain, it will be 1 as a number, or 100 as a percent, guys. Why can't you describe it as certain and the number 1? Certain means it definitely will happen. And if you get the number 1, that means you got all of them out of the total, like 3 out of 3, or 6 out of 6, or 8 out of 8, or I don't know, 15 out of 15. There are 15 outcomes possible out of the 15 total, or 3 outcomes out of the 3, or 6 outcomes out of the 6 total. So you got the whole thing. Or you can use every possible outcome in your sample space, okay? Like up here, this is my sample space. And if it was 6 out of 6, that means I can use all the letters out of all 6. I can use 3 A's, 2 B's, and a C out of the 6 total, which means I can use the whole thing, one whole thing. All right, I'm going to skip 5. All right, and that concludes pages 678 through 680. And the next video will pick up with a theoretical probability.